Okay, good day, Mr. Ronen. How are you in the Israel? So it's me again, Jero Aga. So reporting about some of the topics in the defense techniques, and under the cybersecurity. So the topic that I have choose is the defense techniques. So defense techniques, which is the AAA or the authentication, authorization, and the accounting. So as you can see, the picture or the figure there, they have the triple, that's what you call the triple lock access. So these are the three components, right? So three components or the three core components of the network. So meaning to say, these are the information security that help to control access to resources and uh, to track the user activities or the other activities that you are performing inside the system. So, of course, they have the brief, right? Brief overview. So, let's proceed on the AAA characteristics. So, under the AAA characteristics, we have, of course, the authentication without AAA. So, this is the simplest method to remote access, right? So, this is the remote access authentication to configure a login and password combination on a console, PTY lines, the AUX ports, as shown in the figure. So, some of the, or whenever you are input to the system, of course, they are asking, right? If you have the authentication, of course, they are asking, no? If they are authenticated. So if they are authenticated, of course, you can access easily. So just putting your passwords, right? And of course, I think this is the simplest way to let someone access to your computer remotely. So meaning to say, the requirements also the password and the username. So if you have that and the type of characteristics is the authentication without AAA, so you can simply enter to the system or to the computer. So of course they have also the SSH is more secure form of the remote access. So it requires both username and a password, and both of which are encrypted during the transmission. So the local database method has some limitation. So meaning to say, they have the middle in the transmission. So aside from the username and the password, they have also the computer, right? And the computer is the security. Of course, as you can see the figure, wait, I'm just giving some of the example here. So this is the username and the password. So in the authentication without AAA, of course, you need the key, right? So of course, what's the partner of the key? The lock. So the lock is the password. So if you have the username of or the key, you can use the username to unlock the lock, right? So to unlock the padlock. So this is the password. So they are partner to each other. So if you don't know the username, of course, you cannot access to the second layer, which is the password, right? So username is not enough. Even if you know the username and the password, and you forget the password, so you cannot enter. So it's just like a Facebook account that you cannot log in because you forgot some of the two, right? If you forgot one of them, of course you cannot access. So of course, what kind of medium? So this is the computer and it represents the door, right? So representing your key, the lock, and the door, right? So if you don't have a key, you cannot go to the second layer, which is the lock. And if you don't have uh or if you cannot unlock the lock, you cannot open the door. So that's what it's all about. So think of like having a key username of the lock or the password to open the door or the computer. However, the method is some security limitation. So uh, let's proceed on the SSH or the secure shell. So of course, I make some diagram on this. Of course, they have hello, right? So they're talking to each other, but inside in the middle of that, there is SSS client and the SSH server, or the secure shell client, or the secure shell server. So of course, this is the normal way to talk, but with the power of the secure shell, of course, they have the encrypt and the decrypt. So meaning to say, they have a lock for both parties. So meaning to say, for example, the hello is cannot read by the other aside from the SSH client and the SSH server. So meaning to say, the hello is cannot understand outside the conversation. So meaning to say, the only one who can read is those two, right? The client and the server. So meaning to say, they are encrypted. So that's what you call the secure shell. Okay? So it's just like a force field. You are protected inside the force field. So yeah, acting like a protective shell for your computer. And when you want to interact the things outside the shell, you extend your hand through a special opening that you can control, which is the key. Okay. So let's proceed on the AAA components. Of course, the network and administrative AAA security in the Cisco environment has the three functional components. So of course, in the intro, right? So we are performing, or I'm discussing the level 1 discussion. So this is the AA component, which is they are elaborate more. So the authentication, the authorization, and the accounting or slash auditing. Okay. So the authentication, of course, the user and administrator must prove their identity before accessing the network and the network resources. So meaning to say, of course, you prove that you are one of the employee or one of the student. And if you prove it, of course, they have password, right? So it's not enough if you have the username, but you have both password and the username, or the key and the lock, right? So for example, yeah, I am a user student and I know the password to prove it. So meaning to say, if the what do you call this? If your system is only authentication, so this is enough to enter the system. But we have the authorization. After the user is authenticated, authorization services define which resources that user can access and which operation the user is allowed to perform. So, for example, in there, example, I am a user student, can access the host server using the SSH only. So, meaning to say, by the use of the secure shell or the protective force field, so just like in my example before, so of course they are protected, right? Just to just to protect from the hacker, right? So authorization is answer for that. So how about the accounting? Accounting and auditing, accounting records what the user does. So including what is accessed, the amount of time, resources accessed, and any changes that were made accounting. Accounting keeps track and how network resources are used, right? So meaning to say, it is not enough if you have a AAA and you don't know what's going on the system. So meaning to say, you need the accounting and the auditing, right? Just to show the records, what are you doing inside the system, right? So meaning to say, it is recordable. So you can track, right? So you can track whether it is they have a violation on your what are you doing inside the system, and of course what do you call this, um what the user student, and what's the length of the connection, what they're doing, it's whether it's good or bad. They have the what if they have a breakdown, of course, uh they are accountable, no, based on the accounting records, right? So this is it. So an example, the user student access the host server XYZ using the SSH for 15 minutes. So meaning the 15 minutes there is recorded in the accounting. So that's what you call the AAA components can do. So they have a 3-in-1 security. Okay. So next is the authentication modes. Of course, when you saw the figure there, it is directly on the router only, right? And back to the remote client. So that's what you call the local connection, right? So there's no outside, no, the system. Meaning to say it's between the remote client and the router only. Unlike the server-based authentication, they have a server. Right? The server is the, I think this is centralized access. No, it's just like an internet, and the internet is not limited to the router only, but the router, it connects to the tower outside. So that's what you call the server base. For us to know that they have a connection outside. So yeah, it's like a Facebook, right? Because they are unlimited connect to each other. But of course, we are using the AAA. So more security. Yeah, the local AA authentication. The local uses a local database for authentication. So this method is sometimes known as self-contained authentication. So whatever what it's inside, that's it. Now, unlike the server-based authentication, they have access outside. So with the server-based method, the router access and the central AAA server such as the Cisco Secure Access Control or the ACS for Windows. So which is shown in the figure. That's the figure as shown in the screen. So they have the central AAA server that connects to the other computer outside or the branches, right? If you have the store, of course, you have the branches like a Starbucks, right? So they are integrate to each other by the use of the server. And of course, they have the authentication, which is, this is the server AAA authentication is all about. Okay. So this is it, right? And I have the analogy in the uh, local AAA authentication analogy. So number one is the, this is the title actually. The aspect, of course, the local AAA connection versus the server-based AAA authentication. So the first one, of course, the example is the library. So when you have the library, of course, in the local AAA authentication, the small private library with limited books and versus the public library system with multiple branches. So that's what you call the server-based AA authentication. So meaning to say the table highlights the differences between the local and the server by using the analogy of the library. So on the other hand, we have the authentication location. So where was it where was located? So they say that the authentication location is located inside the library. So device itself, right? Because it is limited. Whatever what is inside, that's it, right? Unlike the central office, right? The authentication location is located on the central office, or which is this what you call the authentication server, right? So meaning to say we have also the user credentials, and then the small library or the small private library, the key is managed locally, right? Locally, there's no outside. That's only inside the library. And the user credentials, of course, the one who manage the library cards. If you have the library cards, of course, they manage centrally. Okay, so of course they have the other branches in record, so they are also access to the other branches. As that whenever you have the library cards, of course you are managed centrally. So you're part of the system. So next is the access control. So the access control in the local AEA is controlled by the library owner, while the server-based authentication is controlled by the central office. So meaning to say the scope, right? The scope of the owner is limited to the one branch only. Unlike the server-based authentication is controlled by the central office, or let's say it is the one who serve the whole or the all the branches. So meaning to say it is accessible by the central office. Okay. So the central office managing the library cards in the public library system, and the library system represents the central control, right? And scalability of a server AAA authentication for a larger network. So it is a large. It's a larger than the local AA connection. So that's the differences. So scalability suitable for smaller libraries devices, unlike the server-based AA authentication is suitable for a larger network or the library system. And of course, the management is direct to the management by the owner, just like on the access control, right? And the one who access to the server-based AAA connection is the centralized management by the authentication server. So that's the power of the authentication. So in terms of the network complexity, limited scope, local interactions. So how many people inside the library? There are limited scope. So there is no access from the outside, right? So unlike the server-based authentication, the wider reach, the interaction across multiple sites. So that's the analogy of the library. Okay, so authorization after the users are successfully authenticated against the selected AAA data source, either local server base, and they are the authorized of the specific network resources. So just like in the figure, this is we prepared to use the server base because we need to have the server, right? Just to connect to the outside. So when we choose to the two, from the two example, of course, we choose the larger. So to have limited people, but the larger scale or the larger security. So that's it. And analogy of the borrowing books from the library. So this is it, right? As an as the librarian, you can control the borrow books from each section. So this is the first section is the science fiction section, and the mystery section, and the history section. So this is the one, this is the authentication part. So you have a three section there, the science, the history, and the history. So the library represents the network or the system with the different resources or section. So the librarian symbolizes the authorization process. So if you have the key card, the library card, so that's the most important thing. So if you don't have that, you don't have authorized. You didn't authorized by the librarian. So the patrons, yeah, that's what you call the patron cards, represent the user account with specific permission. And the markings on the card mirror authorization grant to each user. So if you grant for the science fiction section, so you are authorized only for the science fiction. And unlike the mystery section, if you are limited to use the mystery section, you cannot use the history book, and you cannot use the science fiction section. So you cannot access to that. Okay? So the library cards, of course, if you are granted to those three, edi you're granted for all section. So that's the analogy of the borrowing books from the library, which is by the use of the authorization. Okay, so accounting. Let's proceed to the accounting, and accounting is implemented using the AAA server. The service reports usage statistics back to the ACS server. The statistics can be extracted to create detailed reports. Yeah. But they have the types of accounting information that can be collected are as follows. So number one is the network accounting. Of course, there are tracks overall network usage such as the data transferred. So we need to say you are monitored by how many internet are you using, and of course, how long did you use the network, right? When you connect on the Wi-Fi, of course, you are monitored. So how long did you connect to my internet, or what Mbps, or what data size, or what you call this, or what data did you use, or did you consume, right? So of course, the accounting, they answer how is the amount of data transferred by each department tracked and measured. So what specific data is collected to determine the usage of each apartment? When is the data usage recorded and analyzed for each apartment? Where is the information about data usage stored and accessible? So who is the responsible for monitoring and managing data of each apartment? So they are the specific question to answer the network accounting. So let's proceed now on the number 2, which is the connection accounting, log start and end user session. So meaning to say, the login is recorded, and the logout is also recorded. So that's a simple way to analyze the connection accounting. So they're questioning, or they're asking, the how are the start and end times of user logged and recorded. So I'm going to say who reviewed the connection accounting logs to ensure the proper session management. Yes. And then what information is captured when the user session begins and end. So when does the connection accounting process initiate the user sessions? So where is the data about session start and end times stored? So these are the questions specified for the login and the logouts. Of course, the time, the duration of the connection, it's just like the connection accounting, but in the network accounting it's broad. It's broad. Okay. So next one is the exec accounting, or the executing accounting. So records command execute during the user session. Of course, whatever you do on the internet, it is recordable. So whatever is what are you doing on the network, of course, there are the questions. And how does the system record and log commands execute during the user session? So what type of commands that typically captured through the execute accounting? So what's your action, right? So when does the execute accounting process start recording users command? So where are the recorded command sequence stored for the later analysis? And who has the access of the execute accounting to log to review the executed commands? So these are the questions to answer the execute accounting. So what commands executing during the user session. So next one is uh, the system accounting. Tracks the system-wide activities. I have the example there. For example, you have the electricity breakdown. Of course, it's not your fault that the electricity is breakdown. So you are, uh, what do you call this? Uh, you are trying to solve the problem outside in your system, because your system is not accountable for that. Example, the Meralco. So this is the one who blame to the breakdown. So track system-wide activities, right? So that's why the system-wide is thinking out of the box, or thinking out of your system. So because your system is not only the one to blame to the breakdowns, or the other calamities, or the other contingency in your system. So meaning to say, they are track the system-wide activities. Okay, so how does the system track documented the various system-wide activities? So what kinds of system-level events are included in the system accounting records? So where are the system activities and events recorded for auditing purposes? Where are the logs and the records of system activities maintained? So who is responsible for reviewing and analyzing the system accounting data? So these are the question on how to answer the system accounting. So let's proceed on the command accounting. Of course, uh, I connect it to the example of the programming. So when you say whatever you are commanding on the cell, of course they have a record what command or the history, right? Just like in the Word, in the Microsoft Word, of course, when you undo the actions or the commands executed, they are back to the last executed action did you do, right? So that's the command accounting. So there are the question on how are specific commands executed by the users, captured, and the documented, right? So what is the purpose of the recording and storing individual users' command? So where are the logs, executed commands to store and archive? Who reviews the command accounting logs to ensure the proper usage and security? So this is the question on answering on how to answer the command accounting. So they are all recordable, but they have some of the specific, right? The specific statistics or the specific information that can be collected. So this is the type, this is what accounting is all about. So there are trackings. They are focusing on the trackings. And then the for WH question, of course, you need to answer that. And that's the accounting is all about. And we proceed on the server-based AAA and the characteristics and the protocol. So, of course, we have the protocol there, the server-based characteristics and controls. So, compare local and the server-based implementation. So, one or more AAA servers can be used to manage their users and administrative access needs for the entire corporate network. So meaning to say, when you saw the figures in the screen, of course you have one or more server to that kind of the system. Of course, we're creating or extending the managing who gets the uh, access to your company system. So it may also work with the many external databases, including the Active Directory and lightweight directory access protocol or the LDAP. And these are databases store user account information and password, allowing the central administration user account. So for increase the redundancy, multiple servers can be implemented. So the servers make it easier to manage who gets the access to the company system, and they keep track what they're uh, doing all while providing the backup support. So I think this one of the important from for the server base. Okay. So of course the TACACS or the TACACS plus and the reduce or the RADIUS protocol. So the TACACS and the reduce are both authentication protocols that are used to communicate with the servers. So as shown the next slide, each support different capabilities such as the functionality, the standard, the transport protocol, the CHAP, the confidentiality, customization, and accounting. So yeah, we proceed on the next slide. Of course, on the TACACS and the reduce, in terms of the functionality, the TACACS Plus separates AAA during the AAA architecture, so allowing the modularity and the security server implementation, while the Radius is combining the two A, which is the authentication and the authorization, but separates the accounting. So allowing less flexibility in the implementation than the TACACS. But in terms of the SACACS, the 3A is separated. Yes, according to the structure or the architecture. So this is the analogy of the complex puzzle with different pieces. So this is my example. And of course, in terms of the TACACS, in TACACS, there are the per one expert per AAA. So let's say authentication. One expert verifies the picture. Of course, when we say or when we encounter the word authentication, Of course, the word is the word that it means is the verifying. So you're verifying the picture if the picture is part of the puzzle. And after that, of course, another expert determines where the pieces fit. So this is the authorization. So you authorize the puzzle to fit in the whole picture, right? And in terms of the reduce, both verifies the picture and decides where each fits combining the authentication and authorization. So they are combining two process. Okay? So another keep tracks who's working on which pieces accounting, right? And the other side, which is the reduce, is another team tracks everyone process accounting. Okay? But in terms of the accounting in the reduce, uh they are more detailed. Okay? So in the essence, TACAX gives you specialized expert for each aspect, while the reduce offers more streamlined approach with some trade-offs in flexibility. So that's what the functionality of the reduce versus the TACAX. So let's proceed on the next slide, which is the standard or the aspect of standard. So mostly the TACAX is Cisco supported, while the radius is open RFC standard. So it's just like local or let's say it is near it is not supported by the Cisco. Yeah, that's what open RFC standard is that means. So of course we have the Cisco, which is the puzzle co or the corporation, and the open standard is just like public puzzle part. Okay, so for example, they are not registered. So of course, the Cisco, you are registered. The puzzle co, the company. Okay, so in terms of the TACAX versus the radius, this club has its own unique puzzle pieces, rules, and expert standards, right? So while on the radius, each puzzle manufacturer creates their own puzzle or their own style. So this is what you call the device. And but they all follow the same set of part rules. This is the radio standard. So there is no standard at all because they are not based on the puzzle code. So unlike TACAX, there have the standard which is implemented by the puzzle code. So in terms of the TACAX, it is like the special club with specific puzzle challenges tailored to the puzzle co's style. So they are, it's just like a brand, right? And the other one is not branded. Okay, this allow everyone to enjoy the variety of puzzle without being tied to the specific manufacturer. So meaning to say, they are free to use what everyone's enjoying, right? And in this analogy, TACAX is like a puzzle club with a specific standard for the particular manufacturer, while the Regis is like a puzzle part with open standard and accommodative various manufactured puzzles. So that's what the standard of the TACAX and the Regis. So in terms of the transport protocol, the transmission, they use the transmission protocol or the TCP, while the Reduce is user diagram protocol. So it is like a sending puzzle piece using the reliable courier services. And while on the other hand, sending postcards using a quick delivery services. So this is the one. For example, you are sending, right? Or of course, you have also the courier. So the courier is reliable in the TACAX, while on the radius is just like it's just like a puzzle part. Just like a puzzle part, not branded. Yeah, that's what I understand to that delivery service. So in the TACAX, of course, to ensure the puzzle piece or the data packets are delivered in the correct order and verified. And the radius is faster but doesn't guarantee that all pieces arrive in order without errors. So mostly they have an error. Okay. So it's like ascending pieces or the sending puzzle pieces through the careful and organized figure. So it's just like a lala move. In the Philippines, they're system oriented. Like the radius is not. No, not. For example, you tell your neighbor, hey guys, try to send it to the other neighbor. So just like informal. So there's no system at all. Okay. So in this analogy, ensures the reliable delivery, while the UDP is faster but might have some jumbled piece due to the quicker approach. So the more you fast, of course, the more chances you have failing. Okay, so that's a transport protocol. So in terms of the CHAP, or meaning the challenge handshake authentication protocol. So in this CHAP, you're using the two-way or two-way communication, unlike the radius is unidirectional challenge. So these are the example, the two puzzle enthusiasts, which is Alice and Bob. So in Takax, and Alice challenges Bob by showing him a puzzle piece and asks him to match it. Then Bob responds with the correct match. And also that's the figure is, as you can see in the screen. And also they're back the challenge to Alice. So Bob challenges Alice with another puzzle piece and Alice matches it correctly. So there are the two or bi-directional challenge, right? So they are connected. Whatever you do, and they do it, they going back to you. And this is the principle of the bidirectional. While in the radius is only one way. That's why unidirectional challenge responds from the radius security server to the radius client. So Bob sends Alice a puzzle piece with a question, and Alice responds with a correct piece and matches the question. So that's all. That's what you call the one way. So that's it. And it's like Bob sending a mystery puzzle to Alice and Alice solving it without sending a puzzle back to Bob. So this is what you call the unidirectional. So in these analogies, chop in tax involves a two-way puzzle exchange, while in the chop in the radius is more like a one-way puzzle sent from a sender to a receiver. So that's what you call the one-way ticket, right? So in the other hand, in TACAX, they are going back to you, right? So in terms of the confidentiality, yeah, the TACAX is entirely packet encrypted. So they're encrypt all, right? Unlike the radius is the only password is encrypted. So it's just like a sending a lock puzzle box, then the other one is sending a secret letter inside an envelope. So meaning to say, yeah, just like in the example, of course, the lock puzzle box is lock also the inside. So even though you are unlocked the first layer, you're going to decrypt inside the packet or inside the puzzle box, right? For unlike the sending a secret letter inside an envelope, you're just unlock the outer lock and you can read what's the inside. Okay, that's the doubles. In the TACAX, they're the double security. Okay, so sending a complete puzzle box, that's lock encrypt. That's what you call the lock encrypted. Okay, and this ensure that everything inside the box, including all the puzzle pieces and message, hidden from anyone trying to pick. So even though you can open the box, but you cannot understand what's going on inside, right? They are protected also. Unlike on the sending letter at data packet, where the most important part, the password. So if you are going to unlock the password, or if you're going to unlock the lock outside the envelope, of course they are encrypted in the outside. But if you are going to enter inside and you're unlock the lock, of course you can read what's inside of the envelope. Okay, so the rest of the letter might be seen. So, but most crucial part is hidden, okay, which is the lock. Okay, so in these analogies, they say that the TACAX plus encrypts the whole puzzle box, ensuring the complete confidentiality, while the radius focuses on the encrypting the password, keeping the critical part secret. Other parts might be visible. Okay, so customization. Of course, in TACAX provides authorization of router commands on the per user or per group basis. So the radius has no option to authorize router commands on the per user or the per group basis. So meaning to say, it is the example of the different levels of difficulty for each. While on the puzzle part, so generic with set challenges. So it's just like you allowing to customize based on the skill set that you have. Now, unlike the puzzle part, whether it's easy or difficult, there is no changes at all. Okay. So in TACAX, allows you to customize the puzzle challenges for each user or group, like giving advanced puzzle to the experts and simpler ones to the beginners. So yeah, this way everyone gets personalized puzzle experience. So they are more accurate, right, than the reduce. So in terms of the reduce of the customization, the challenges are same for everyone. So they are constant, right? So there is no changes at all. So you don't have the option to personalize puzzle for different user or groups. Okay. So in this analogy, the TACAX offers the personalized puzzle challenges for each user or group, while the reduce provides the same challenges to everyone without customization. Yeah, that's it. And TACAX, in terms of the accounting, in the TACAX class, the accounting is limited, right? Limited. And while in the reduce is very extensive. They are more detailed than the TACAX. Because the TACAX is, it's a basic statistics, while in the reduce is the inferential statistics that you are applying to that accounting or for their accounting purposes. Yeah, the puzzle with different level for each difficulty for each and the collective comprehensive puzzle statistics. So in the TACAX, you're only able to collect the basic information about who completed which puzzles. And it's just like keeping a simple record of which puzzle were solved without detailed insight. So yeah, that's a basic knowledge, right? It is a basic because you are asking for a simpler record, right? Unlike the reduce goes beyond just knowing who completed the puzzle. It is also records how much time each person spent, which pieces they are struggling with, and other detailed insights. So they have a better data to study. So that's the specialty of the reduce protocol. Okay, it's very extensive. Okay, it's just like having a detail to plug every puzzle solving each step. So it's just like on the game. So they have the notation, they have the mappings, they have the coordinates that you are trying to locate the location. Okay? So yeah, in this analogy, TACAX provides the limited puzzle completion information while the reduce offers the extensive statistics and insight about the puzzle solving activities. So that's it. Right? So in the Radius of Authorization, Radius is an open IETF standard a protocol for the applications such as the network or the IP mobility. Radius works on both local and roaming situation, and it's commonly used for accounting purposes. So this figure shows the authentication processes. So yan, from the first stage, you are going to asking the username also. And of course, when you answer the question and the username is accessible, of course, you can enter to the next level, which is the password. And of course, uh, you're trying to put your strong password. Yeah, or the encrypted password, yeah, just like shown on the figures. Okay, and also the access request, when you enter the strong password, of course, their access accept. Okay, the Redis protocols hides the password during the transmission. Yan, that's what you call the password authentication protocol or the PAP. So using a rather complex operation that involves the message digest pipe or the MD5, hashing and shared secret. So just like my example on the force field or the shell, the C shell, the secure shell protocol. Yeah, that's we're all about the reduce because they're protecting the password, but the content is not. Okay. And of course, the specialty of the reviews is combined authorization and authentication as one process, two-in-one process. Okay, in terms of the functionality. Okay, let's go on the access control limits or the ACL. Of course, ACL stands for the access control limit. Okay, so it is what do you call this? It is security feature used in the computer system networks to manage the control access to the resources. So the files or the directories or the services. So ACL is defined which the user or system processes are granted permission to perform the action on the specific object resources and what actions they are allowed to perform, such as read, write, execute, or delete. So it's just like on a programming security that you're applying. So they are commonly used to the operating system, the file system, the routers, and the network devices to enforce security policies and the strict unauthorized access. So they provide a fine-grained level of control over who can access and modify data, uh, helping organization maintain the confidentiality, integrity, availability, and the information and the resources. Okay. So, uh, that's what ACL is all about. Okay, and this is some of the example that they are answering the task. Okay, so an ACL series, the iOS commands the commands that I use to filter packets based on the information found in the packet header. So the task is limit network traffic to increase the network performance. So of course, that's logically, right? So a corporate policy prohibits video traffic to the network to reduce the network load because the video is it is a large size. So of course, the memory would be affected, right? They are causing lags, they're causing high consume of the network. And of course, there are also the policy. So a policy that can enforce using ACL to block video traffic. Okay? So they are limiting the network traffic to increase the network performance. So that's what task is all about. Then next task is provide traffic flow control. So this is the task. So let's say the problem is a corporate policy requires that the routing control traffic be limited to the certain links only. So they are limited to for able to uh, implement the restrictions, right? So the policy that they are implemented is the using ACLs to restrict the delivery of routing updates to only those who came from known source. So if your source is unknown and you cannot enter, right? And this is the control that they are provide to the traffic. Okay, and then the next task is provide a basic level of security for network access. So they say that the corporate policy demands that the access to the human resources network be restricted to authorized users only. Okay, so a policy that the policy that they implemented is they enforce using ACLs to limit the access to specified network. So of course, if you have or if you're part of the human resource network and it is restricted to the authorized users only, of course you can access to the network access. Yes, you can access for that. Because you are one of the HR or one of the human resources or you are HR manager, of course you're in the system. Okay? So next task is the filter traffic based on traffic type. So corporate policy requires the email traffic can be permitted into a network, but that the telnet access can be denied. So the telnet access or the telephone internet. Okay? They denied because uh, your em your email is not permitted to the network. So the policy that can be implemented, using ACLs to filter the traffic by type. So, for example, your email is permitted and the other email is not permitted. So, of course, the first who came to the traffic, the first come or the first one who can pass or who can enter is the one who are permitted to the network. So, I mean to say they are blocks. Okay? And then the next is the screen host to permit or deny access to network services. Of course, it is one of the important, right? So the corporate policy requires the access to some file type, which is the FTP or the HTTP, be limited to the user group. So meaning to say, if you're open the MP4 file, you cannot enter if the if the accessible file type is HTTP or the FTP. So you cannot open that kind of file type, just some file of types that are not HTTP or the FTP. So meaning to say, you are going to open only for the FTP and the HTTP. Okay, be limited to the group. And the policy that implemented, of course, using the ACL to filter the user's access to the services. Okay. So the last task that uh, we are performing the ACL is the provide priority to certain classes of the network traffic. So the problem is corporate traffic specifies the voice traffic be forwarded as fast as possible to avoid the interruptions. So of course the policy that they are implemented is using the ACLs services to identify the voice traffic and process it immediately. Okay? So they are providing the priority. For example, in the expressway. So if you have the QR code, or if you have the what do you call this, the chip, the chip when the wireless chip. So meaning to say you can enter easily, right? Because they're priority, because they're uh they're faster. Okay, unlike to the person without the chips, right? Or the pass card. Of course, they're verifying and you are paying. You are paying. And that's the provide priority to certain classes to the network of traffic. That's what prioritization is all about. So that's all for the ACL, and we're going to proceed to the packet filtering. And the packet filtering controls the access to a network by analyzing the incoming or outgoing packets, forwarding them, or discarding them based on the given criteria. Packet filtering can, of course, when you open the OSI model, the transport and the network is connected to each other. That's why there are the number 2, the number 3, and the number 4. And of course, when you are going to that layer, uh, of course, the controls of what's incoming or what's outgoing, only two can control that. Okay, to that layer, the layer 3 and the layer 4. So let's go back to the numbered and named ACLs. So yeah, in the screen, in the screen shown in the screen, and the number ACLs numbers 1 to 9 or 1,300 to 1,999 are what you call the standard, uh, is the standard ACLs, while the ACL number 100, 199, 100, 199, and 2,000 to 2,669 are the extended ACLs, but they're called ACL, access control, right, to the output. And they are prepared the method for the configuring ACLs, especially the standard and extended ACLs can be named to provide information about the purposes of the ACL. Okay, and the IP access list global configuration command is used to create the name ACL. Yeah, just like on the screen what are shown. Okay, so it's not just like a number, but the number has a meaning, right? they're the specific type or the specific standard that they are follows. Okay, so it's not like a number. Okay, that's why what you call the number and the name ACLs. So they are the name inside the number. All right. Okay. So the ACL operations. Yeah. Now when you say the inbound ACL and the outbound ACL, yeah, they are defined a set of rules that can give the added control for the packets and their inbound interfaces. So packets that relate through the router, uh, the packets and the exit outbound interfaces of the router. So as the figure shown in the screen, the inbound ACL, of course, they are the one who controls what's incoming. Unlike the other, on the other hand, the outbound ACL is the one who control the outgoing outgoing things or outgoing actions. Yan. So the inbound ACL is applied to incoming network traffic. So determining what is allowed or denied, and when data enters to the network or services. And it filters the traffic coming from the external sources into an internal network. So when you say the outbound or the egress, so meaning out, right? So is applied to outgoing network traffic, determining the allowed and the denied, the data when the data leaves to the network or device. Okay, so it filters the traffic going from the internal network to out the external what do you call this? The external destinations. Okay, so that's the ACL operations. Okay, so let's proceed on the wildcard masking. So when we say the wildcard masking, it is a concept used in networking, right? So what particular networking? It is inside in the ACL or the access control limits to specify with portion of an IP address. So they have the presence of the IP address, and of course not only the IP address but also the subnet. Okay, so there's a two presence in the wildcard masking because the subnet is the wildcard masking, right? And whether to ignore or to uh, allow or treated as a wildcard, and it is the inverse of the subnet masking. Okay, so they're inverse to each other. Okay, so next is yeah. Next slide. So we have the wildcard mask overview. Of course, when we say the wildcard overview, the wildcard mask is like a subnet mask, right? But it is uses the ending process to identify which bits in an IPv4 address to match, right? So however they differ in the way they match binary 1 or the 0. Of course, we know that the 1 and 0 is on and off. But in the wildcard masking, it is the reverse, right? Or they are reversing the function, which is the 0 is match and the 1 is ignore. So they are inverse, right? So that's why this is the wildcard mask. Okay, so when we say the wildcard mask, we have the octet, right? So this is the 4 0 that are shown in the table, and the last octet in binary form is the number on the last octet, but they converting to the it converts to binary form. So that's why the binary is like 0101. All right. So and this is the meaning of the 1 and 0, which means the 1 is ignored and the 0 is matched. So meaning if the wildcard mask has the 0000, of course, uh, uh, for me, this is allowing access from any any source of the IP address. So meaning there's no restriction and match all octets, right? So that was the wildcard mask with the 0.0.0.0 is all about. Okay. So next line is the orange one that are shown in the table. This is the 0.0.0.63, and we have the binary form of the 20 on the leftmost and the 6 zeros on the last 6 bits. Okay, so what does it mean? So the meaning of this wildcard mask is the match the first 3 octets because they have the presence of the 30 on the front and the last octet is the 63. So meaning to say when we convert it to the binary, of course we are allowing or denying the octets, right? So based on the bits that are shown in the binary form. So meaning to say, match the first 3 octets. Next one is the match 2 leftmost bits on the last octet. And ignore the last 6 bits. The last 6 bits is the 6 ones on the binary form. So they're allowing access from a specific subnet, like how do you call this? Like the 1.9.21681x. So the last octet is the x. Okay, so whatever the number is in the IP address, so you will allow the first 3 octets on the IP address, and you are focusing on the last octet, which is the x. For example, we put x on that last octet, and of course, we are allowing value. Any value from 0 and 63, right? So that's why the last octet present on the wildcard mask is 63. So we need to say we are ignoring the last 6 bits, right? So the next one is the green, the 0.0.0.15, or in the last octet in the binary form is 4 zeros on the left and the 4 zeros again to the right side. So meaning to say 0, 0, 0, 0, 0, 1, 1, 1, 1, 1. So they said that we are going to match the first 3 octets and match the 4 leftmost bits of the last octet. Then ignore the last 4 bits of the last octet. So meaning to say we are allowing access of the IP address with ranging from what do you call this, the 240 and 255. I mean, that's what the 4 bits is all about, because we're going to when we're going to convert it to the numbers, it means that you are going to allow the IP address like 240 to 255. So when the numbers is in between of 240 and 255, of course you're allowing the IP address like that. Okay? So the third one is the 0.0.252 or the 1111100. So 6 ones and 2 zeros. Okay, so that means that you are matching the first 3 octets. Of course, the IP address with the first 3 octets is allowed. So match, right? But you're focusing on the last octets, which means that you are ignoring the 6 leftmost bits of the last octets and match the last 2 bits. So meaning to say you're allowing access subnet like whatever the 3 octets on the first, whatever the first 3 octets is, you're allowing it. And then you are focusing to the another last octet, allowing access. So any value can be 2 bits. So it's set to 11, for example, 11, 3, 7, so by 2s, right? Because you are matching the last 2 bits. So that is important one. Okay, so that's why any value from the last 2 bits are the by 2s form. Okay, so that's what it means. And the last example in the table, you are the we have the 0.0.0.255, and the final binary or the last octet in binary form is all 1, right? So 8 ones, right? 8 ones is the present in the last octet. So meaning to say we are matching the first 3 octets and ignore the last octet, the whole last octet. So meaning to say allowing access within a specific subnet regardless of the last octet. So meaning to say it is a reverse of the wildcard mask 0 on the first example. Match all octets while the last example is ignore the last octet, right? But you are matching the first three. So that's the difference between the two. So meaning to say, this example are demonstrating how the wildcard mask is applied in ACL to specify the IP address are allowed or deny or range of the this then allow or deny access on the patterns or ranges pattern defined by the mask. So that's overview of the wildcard mask. Okay, so next we have the wildcard mask type. So we have the three. We have the wildcard mask to match the host, and the one is the wildcard mask to match an IPv4 subnet. And the last one is the wildcard mask to match an IPv4 address range. So we have that three tables in the screen, and they are showing that in the context of the networking and access control list or the ACL, a wildcard mask is used to specify which parts of an IPv4 address should be matched or ignored when determining the particular address is allowed, okay, or denied with we in the or into a network or a source. So let's break down the example that we are provided. So in the next slide, of course, yan, we are showing that the wildcard must to match the host. So now we have the IPv4 address of the 192.168.1.1, and we are converting them into a binary form. And we have the wildcard mask of the 0.0.0.0.0. So based on the wildcard mask overview, of course, we know that the permitted IPv4 address is matched to the IPv4 address. So we need to set this is matched exactly, right? So since bits of the wildcard mask is 0, essentially says that it is matched to the it is matched to the IPv4 address. So IPv4 address must match exactly and equivalent to specifying a single host address. The permitted IPv4 address is, of course, the IPv4 address that are shown in the table. So we need to say there's no changes. Okay, all bits must match precisely, and because of the wildcard mask equals to 0. Okay, so that's what it means. Okay, so next one is this is the wildcard mask type. So meaning to say, wildcard mask to match the IPv4 subnet. So meaning to say, this is we have the same IPv4 address before, and they're converting also to the binary form. And we have the wildcard mask of the 0.0.0.255. So we ignore the last octets and match the first three octets. So that's what the overview means, right? So meaning to say the permitted IPv4 address is 192.168.1.0.24. So what is the 0.over24 means? So this is the notation. It is represent that the IPv4 address range using the shorthand called the CIDR, or the classless interdomain routing notation. Okay, so it is used to specify the subnet, and it is associated to the subnet mask. And of course, this is the breakdown. Okay, so in the IPv4, they are specifying that the range of IPv4 address within the same subnet is permitted. Okay, so what kind of permitted? So the IPv4 address range covers all hosts within the subnet of the 192.168.1.0/24. So meaning to say the first 24 bits match exactly, and the last 8 digits can vary to represent different hosts. So the network address should be 192.168.1.0, and the usable host address is should be in between of the 1 and the 254. Okay, because the 255 is the broadcast address. The one who sent, okay, the one who sends the address to the other addresses. Okay, so this is the living address. Okay, so that's what the third wildcard mask type is all about. So they're in between. So you are choosing, or what do you call? They have the two parts, right? And then the network portion and the host portion. So you are able to identify what's the host and what's the network portion. So meaning to say, this allows to the total of unique host address within that subnet. Okay, so yeah, they have a range, right? And the next wildcard type is, yeah, we have the double range. We have the 0.0/2 and the 0/24. So we have the two range. Okay, so let's say we have the 0.15. So we have the third octet aside from the last octet. So they should have the function there. So they have a meaning. Okay? So if we convert it to the binary form, so the 255 there is showing that uh, all 8 digit is equal to 1. So 1, 1, 1, 1, 1, 1, 1. While in the 15 is equal to the 1, 1, 1, 1, 1. Okay, 0, 0, 0, 0, 0, and then 1, 1, 1, 1, 1. Okay, so meaning to say they have the two, you are going to having ignore the last octet, but in the binary form, you are going to match the first 4 bit in the third octet and the final and the last 4 digit in the third octet. You are ignoring it, ignore and allow or match. Okay, because of the 000 there. I mean to say the permitted IPv4 address range is 192.168.16.0/2 up to the 192.168.31.0/24. So it covers all the IP address from the 0 to 55. And of course, you are considering that the third octet is between 16 and 31. So where the first 4 bits, the last octet can be vary. Okay, and the rest of the address bits match the provided address is 192.168 point 1. So wildcard mask indicates that the first 4 bit, yan, that I said a while ago, you are going to consider the third octet, not just the last octet, because the masking is not a 0, right? You're matching the first 2 octets. But in the third and the fourth, they have the case-to-case basis. And you are going to follow what's the overview on the previous slide. Okay, so it can be 0 or 15. Okay, and the next one is the wildcard mask calculation, meaning to say, calculating wildcard mask can be challenging if you have no calculator, of course. And but right now in towards to the industrial 4.0, of course, they're easy because we are using the high technology calculator in the inside the computer. So we need to say the computer is the one who solved this calculation. So when it comes to the normal calculation or the manual calculation, of course it is hard. Okay, so one shortcut method is subtract the subnet mask from the 255. Okay, the 255, all the octets. Okay, we have the starting value of the 255, 255, 255, 255. Okay, minus the 255, 255, 255, and 0. So the resulting wildcard mask is 0.0.255. Okay, it is a simple what do you call this? It is a simple subtraction, right? Because you are converting it to Indo-Arabic numbers, right? Well, if you have to convert it into binary, it is challenging. It is more challenging. So assume that You wanted an ACE in ACL to permit the access all users in the 192.168.3.0 over 24 network to calculate the wildcard mask subtract. Okay, as shown in the figure. Okay, and the solution provide the wildcard mask of 0.0.0.255. So this is the new wildcard mask. Okay, therefore the ACE access list 10 permit the 192.168.3.0 and add the wildcard mask on the access list 10. Okay, so what's next? Of course, the resulting wildcard mask is included also in the overview. So there's no problem with that because they have the meaning. Okay, so meaning that you are matching the first three octets and the 255 when we are converting it into the binary. So we already know that they have the function itself. Okay, so next one. Okay, the wildcard mask keyword. So we have also the keyword there. Okay, so we have the host, we have the any. So meaning to say this word substitute to the 0.0.0.0 mask or the zero mask. This takes that the all IPv4 address bits must match to filter just one host address. So meaning to say the host word indicates that this we're going to useful define the ECE for a specific host. So you're going to uh, filter the traffic into a single host. Okay, well, in the any, if you have the keyword of the 255.255.255.255 or the 4255 in the IP address there, this is the mask. Okay, and the mask essentially means that you are ignore the entire IPv4 address or accept any address. So there's no restriction there. Okay, and it's commonly used when you want to create the ACE that allows to traffic from any source or to any destination. Okay, so by using these keywords, of course, this is very important because you can make an ACL configuration. Okay, more concise and easier to understand, especially when when dealing with a specific host address or allowing traffic for any source or to any destination. So just like what on the screen, okay, what that the figure shown on the screen. So for example, with this the ACL command. So that's what you call the configuration, okay, or the ACL configuration. Okay, so and that's it. Thank you for this opportunity to have a recording, Sir Ronan. So have a nice day, and I'm glad that you're doing a productive day and also trusting to God. So bye bye, sir. Thank you, and I hope you're watching it and understand some of my discussion. So whatever your question here, please message me on the WhatsApp. Okay, thank you. Bye bye.